Welcome back for the second part of our class today, and now we're moving on to scientific notation. So why do we use scientific notation? Well, we are very accustomed to writing numbers in standard form, but scientific notation lets us take these long numbers that have lots of zeros because they're so big, or lots of decimal points because they're so small, and write them with fewer digits and less writing. So we need to figure out how to put numbers in scientific notation, especially for when we're measuring distances in the solar system. So distances to the sun, distances of radius or diameter around a planet, or if we're taking the mass or how much volume a planet has. So just a few notes about what is scientific notation here. So we'll take this example of 5.2 times 10 to the 12th. The coefficient is this number sitting in front. So it has to be greater than 1 or less than 10. So it's going to be a number with a decimal. So 9.0 would work, but 10.0 wouldn't work because that means you have two numbers sitting in front of the decimal point. So then this 10 would be better written as 1.0, and then we would increase its exponent one more. And that'll become clear in just a second. All right, the base is always going to be 10. Always 10, that doesn't change. And then finally the exponent. So this is going to be the number of times you're multiplying by 10. So the number of times multiplied by 10, or in shortcut, the number of times you move the decimal point. The number of times you move the decimal point. So let's take two examples because it's very, very easy. You just take it, you move the decimal point this number of times, and the problem's over. So let's take another number. Let's take 8.5 times 10 to the 5th. All right, so we have a very, very big number here, and it's written in exponent form times 10 to the 5th. So I want to convert it back to standard form. Well, all you do is you take it, write it again, 8.5, move that decimal because this is a positive exponent. You're going to move it 5 times to the right. So remember, the decimal point is here in between the numbers 1, 2, 3, 4, 5. And make your new decimal point, and then fill in these other blank spaces with zeros. Write that number again. So 8, 5, and then 1, 2, 3, 4 zeros. 1, 2, 3, 4 zeros. Put my comma in here if you want. It's totally optional. So we have 850,000 of whatever unit that was. Notice 4 zeros, but my exponent was 5. Where'd that other decimal place come from? It was because my coefficient already has a decimal place. So that takes up the 1 and then 4 zeros past that. So very, very easy. Now let's say we have a small number. So let's say I have 0.000112. So a very, very tiny thing. So how do you make that into scientific notation? Well, you just work backwards. So we have 112. So one digit with a decimal point times 10, and now let's count how many times we need to move the decimal to get it to this place just behind the 1. 1, 2, 3, 4 times. So this is going to be -4 because it's a very, very small number, so it has a negative exponent. That's pretty much it for how to do scientific notation. You're either moving the decimal to the right or to the left, counting the number that is in the exponent. All right, so your worksheet for this exercise is to look up information on the internet about the planets. So we've been studying the planets in the solar system, and now I want you to figure out, using this chart, the distance from the sun of the planets, the radius of the planet, and its mass. All right, so distance from the sun, radius, and mass. Notice all in metric, kilometers, and kilograms. So let's do an example together. How far is the Earth from the sun? Well, the Earth is 149,600,000 kilometers from the sun. So there's my really, really big number. How do I take that into scientific notation? Well, you put the number with the one decimal, 1.496 times 10. And then how do I get the decimal into that position? Well, the decimal's out here behind the last zero. And then I count 1, 2, 3, 4, 5, 6, 7, 8. 8. So 1.496 times 10 to the 8th would be the answer for the distance from the sun in kilometers in scientific notation. All right, so you're going to do that a couple more times for all the other planets. And then you look up then its radius and also its mass and finish filling out this table. And once you're done with that, I want to ask you, is there a relationship between how far a planet is from the sun, its radius, and its mass? Is it always in order? Are planets that are further from the sun more mass, less mass, bigger radius, smaller radius? So in a sentence or two or three at the bottom of your paper, you're going to answer this question about what is the relationship between distance from sun, radius, and mass. All right, thanks for listening, guys. I hope you have a great rest of class.